Hello students, welcome to EduCell. In this video, we are going to discuss about set cover, a general greedy heuristic. Here, I have kept the content of two different books. One book is written by Corman and other co-authors. Another book is the Eva Tardos and other co-author, which book named as Algorithm Design, and other book named as Introduction to Algorithms. Okay, as I have told you many times in the videos, I am following the book through which it will be more easier to you to understand exactly what is it's written there inside. Okay, so basically the set cover, what we have already discussed earlier in the reduction time, set cover is some you can say there are subsets. Okay, there are certain subsets where I have also kept the example for you to understand, but initially we should know what we should say how a set cover will look like and why it is important for us. Okay, that we will be discussing again. Set cover problem, when we have decided to find out a set cover means there are you just think there are set subsets. Suppose I am keeping set as S, where I am keeping the elements like 4 5. This is just a set for us, or universal set for us, which named as U or C you can say. Okay, so here I am kept as S, capital S for it. Suppose S1 I am keeping, which is a subset where I am keeping 2 3. There are three elements I'm keeping. S2 I'm keeping where it is 4 5, or S3 also I'm keeping, which keeps 1 2 4. S5 I'm keeping, which is 3 uh, 3 4 and 5. These are certain subsets we have. Okay, so in general the subset will be, the set cover will be those subsets we are trying to find out. Basically we are focusing on the minimum number of subsets through which we can cover all the elements. Basically we want to give all the elements by selecting those subsets which are having the elements. If we combine those elements, the total elements will be the, or forming the universal set, which is S here. As for the example, you can see if I'm combining, like in a set we should say it's union when we are adding it. Okay, so suppose I'm adding this one, so elements within this 1 2 3, here also I'm just keeping with by using union. Okay, I'm just adding that one 4 and 5. So what exactly it gives us? 1 2 3 4 and 5, which is the set. Clear? Which is the universal set through which we are getting the all the elements which are getting combined. After combinations of small s 1 and small s2, we are getting this value. Okay, now the next is whether you have a doubt, like we can combine with S3 or we can combine with S5 or not. You can combine this one 1 2 3 then 4 5. Also it will give you the same result as we are getting from the S also. S3 union S5. Suppose you are doing it 1 2 4, then union 3 4 and 5. Suppose you are doing this one 1 2 3 4 is common, so you keep that one. It is also giving the set cover. Clear? So the main reason exactly why we are adding them, then why approximation is getting used. We know we can take one by one element, we have to check it, we have to like we have already seen the algorithms there. Using vertex cover we found a set cover. Okay, we have seen that one also. But here what the problem, why we are then focusing using the approximation algorithm? This is a biggest question nowadays. Okay, so first of all we should focus what are the new changes are being done. Okay, so here you can see it's a NP completeness is getting added, like it's a part of NP complete. Why we say if vertex cover, through vertex cover we are doing the reductions. If vertex cover is NP complete problem, definitely it should be NP complete or more than that, but it should not be less than NP complete. Why? Because if you are trying to reduce something, suppose as I have already told you, suppose it is written like this: A is polynomially reduced to B, means B is depending on A. Okay, once A you are getting as, suppose A is n square, as we have already informed again and again, I'm just saying you the exact point here why we are focusing this one. Okay, so n square, suppose we are getting the value a as n square and we want b to be resolved using a, so we can expect at least it should be n square or more than this, or more but not less. Means n to the power 1.5 you cannot expect, because you are fully depending on a. Okay, through a you are trying to reduce it, you're trying to reduce to get the value of b. This is what we tried for earlier videos. You can check there. Set cover, when I trying to find it out, you have taken the help of vertex cover. Through that, you know, the set cover you found out. So what exactly they have changed here? Like u is the conventions, you just remember. These are this content I kept from the Tado's book. So here use a set of set where it gives n number of elements, and this capital S1 to up to Sm, which are the number of subsets. Clear? Number of subsets belongs to this u, and S1 S2 up to m subsets are there within the u. Okay, which is universal set. Next, what we are exactly doing here, we are associating one weight to each subset. Okay, here it is written as set. You can say within, if I'm saying the universal set, so within that what are the subsets within that, we can say it's subset. Okay, so here in the book they have written it's set Si. Suppose you are just focusing on a subset, you can say these are for subset Si. There will be each subset. Here we are just focusing on the elements, so they are assigning just an weight to it. Weight, why? Because you know, if I'm saying vertex cover is okay for this too, like I have taken this example to make you better understanding of it, I'm just assigning a weight to it. Okay, suppose the weight I am saying is 2 here and 1 here. Here I'm giving the weight wi. I'm just representing as wi. Okay, so this is 2 and this is 1. Here this is 2 and this is 2. Once we are doing it, what the cost we are getting for this, the weight we are exactly getting is 2 plus 1, which is 3. For this case, we are expecting the weight, the total weight. I'm not saying this is a single weight. For single weight, W of I. For each element, each set of I. So we are having certain cost of it. So I'm just removing that one, and I'm just saying it is for W, means the total weight assigned here is, like we are taking the help of 3 and 5. So here 2 plus 2, which is 4. Our goal is we have to complete the set cover by taking the set of elements. Okay, the subsets what are there, but the cost should be less. This is what we are assigning here. Okay, the cost we should have to finalize. The cost or the weight assigned to each subset should be minimized. So the goal, it is written, the goal is to find out a set cover. Set cover represented as C. Okay, a capital C you can say, so that the total weight we can say in this format. Why? Because if this Si is representing as like the subset which we have picked, the subset belongs to the set cover. Okay, if you have said if you say the set cover is this one, so the set cover is S1 and S2. The set cover, if I'm saying S, so the set cover you can say is, this is your set cover. Okay, so this is your set cover, which says like each weight that is getting assigned to each subset will be the less or will be minimized. It is clearly mentioned our goal is to find a subset, no doubt, but the cost which we are assigning or the cost which we are getting, the total cost should be minimized. Here the total cost we are getting, the total cost, you can say, if I'm writing in this way, S of I belongs to C, as I have already told there, and W of I means for first element it is 2, cost is assigned as 2. Okay, next cost is assigned as 1, so then the cost we are getting is 3. There also we will run it and we will got we get this one as 4. So based on this we are picking this 3, which is our minimum weight, will be picked for the subset set cover. Okay, and those subsets will be the optimal for us for a timing. We are just doing the approximation here. So in general, when we say let us think the weight assigned to each subset is 1. Based on that, if I'm saying 1 is there, okay, like we have done bipartite maximum bipartiteness when we were finding out in network flow. That time we assigned all the edges for the timing is 1. Or you can say the better example also when we tried with the reduction of Hamiltonian path as well as the traveling salesman. When we tried with that one, we initiate all the edges for all the distance connected to each cities as 1. Why? Because indirectly we are saying if it is 1, then we run it smoothly. So if you say the weight assigned to all the set or all the subsets within this set, if it is 1, so we can find it out. Yeah, the minimum is this much. So where it follows the k, as we have already discussed, k is the number of subsets through which you are trying to make a set cover. Suppose I said you, like you just take k as 2, means 2 subsets will be selected, and from these 2 subsets you are going to make a set cover, means you are completely cover all the elements within that. This is what k represents. If the weight is 1 to all, so in that case we will focus to k, because k is given. Those who are new, kindly watch the previous video where we discussed about the set cover introduction. The set cover introduction, there we initialize with the k value, and certain sets are there through which we are trying to manage how many sets, how many subsets we are picking to make the set cover. That k represents that value, some integer value we have. So this k, depending on k, we are trying to find out a set cover. This is what the introduction is. I hope it is clearly understood to you. Next, we will focus this content is Corman content, the book there it, like I kept the content from the book written by the Corman and other co-authors. So here the naming convention is just different. Here F represents all the subsets. Here it is represented as F. Okay, as I have already given you the example also. Okay, in the example, these are certain subsets. S1 is a subset of the set. Okay, and S2 is also subset. S6 is also subset, and S4 is subset. S3 is subset, and S5 is subset. Why I kept this one? To give you the better example of why we are fixing off the intersection. Why intersection is important. For that I am just keeping this content, then we'll switch to the Tado's content, or the content written by the Tado's and other co-authors. Okay, so it is a Corman. Basically I am following Corman book. From this, these are being written. So X represents all the points within this set. Here the set we have 1, 2, 3, 4 up to 12 points. Here it is written as X consists of 12 points, 12 black points. F represents the subset of, F is just universal set. Within that there are subsets named as S1 to X6. Okay, next U, they are initializing U, where uh, they kept all the points to U, by because we are trying to operate on it. Okay, that's why we are introducing one more variable named as U. Next, C represents the set cover. Okay, it's initially set to be 5, means there is nothing inside it. Next, we will run a loop through which what exactly we are trying to say. The loop, even if we are running, so we are basing on the number of elements present within the U. Okay, so here while we said capital U is until it's 5, means until it is not having any numbers, we will run that one. Until it is 5, we will be running that one, and select S. S represents a subset which belongs to a set that we are trying to find it out. Next, what exactly we are trying? Maximizes. If we are getting any maximum number of points, that will be selected. So that's why we are saying in this format. Why then? You can check. If I am saying S1, S1 is having the maximum elements are 1, 2, 3, 4, 5, 6. How do I find them? If just think this one as just a certain a number for us, 1 2 3 4 5 6, and f, which is all the numbers 1 2 3 4 5 6 7 8 9 10 11 12. Okay, suppose how do you then know uh, to find out which one is a maximum? For that reason we are just giving of an example. Okay, so you are doing the intersection of it, so definitely you know intersection will give you the same value if s1, and this mod sign represents how many number of elements that you have. Clear? If it is 6, based on like for s1 it got 6, for s2 it got 4, because within s2 1 2 3 4, like there are also, if I'm saying s4, there are 1 2 3 4 and 5. This is subset. Okay, this subset, so that's why we have a boundary for all the subsets within the sets to give you the better example, better idea about how we are finding out. Okay, so that's why we are picking the the intersection of the universal. Okay, next u, once we found out s to be selected, then the numbers or the points existing there before will be subtracted from the selected node. Suppose I am selecting s1, so rest of the elements present there are, like if I am just doing u previously x means the 12 points which are there will be set to be these points, and s will be from 7, then 8 9 10 11 and 12. This is now it left. If I say u equal to u minus s, this represents the value. Then the c said you do the union, you add the s1 to the cover set cover. If it completely if it completely have a phi or might be nothing is there, then then you have to stop and you have to give the result. The first time you are getting as s1 will be selected. Now we have other points also. Based on those points, as I have already told you, the maximum will be picked. Next maximum is, these are 6, the next maximum is, here is 4, here is 4, here is 2, here is 4, here is 5. So s4, if I am picking s4, so definitely what we can find it out, like 5 elements will be finalized. So 5 elements you can say either 7, 8, 9, 10 we will be saying as these are the elements, so we can find it out. Next, one element has to be covered. So for getting one element to be covered, next though we are following the greedy approach, there the next minimum is either you can pick this one s5 or s2, because 4 elements are there. So I'm just picking s5. Next elements to be picked as like this one will be covered, this one will be covered, and this one will be covered. Only one point is there. If you want to cover one point which is there, either you can select a 3 s3 or you have to select s4. Clear? This is what you have to focus. Sorry, s6, because s4 is already being selected. This is important. And for selecting this point which is left, what we have to do, either we have to pick s3 or we have to pick the s6, because there are two options we will be having. Okay, so in this way what we did, like we initially in this book they have not mentioned with the weight. Okay, when they form with the theorem, that time they have taken care of the weight. Okay, but in this approach, in this algorithm, they have not mentioned any weight. Okay, so the time complexity, if we should know the time complexity, it will follow the number of points with the minimum number of the points with the sets there. So this is the time complexity. I hope it is clearly understood to you. Then I'll focus to the Tardos content. Okay, the content written in the Tardos. Now you focus. If weight is not 1, if weight is not 1 for each subset, then how do we find out the algorithm? So here they are concentrating if weight is not 1, suppose. Okay, Clear? Greedy set cover, they started it, and R, they have taken one R, which is equivalent to U, means the number of elements. Uh, as I have already informed you here, U represents n number of elements. Same thing, we are just transferring that in R. Why? Because we will be doing the operations in R. Okay. No sets selected. Initially, we have to say no sets to be selected, and we will just initialize the R value. Next, we will run while loop. As we have already done with that one, we have to focus on the number of elements. Okay, it's until it is 5, means until the elements doesn't have any elements, we have to run that one. So what we have to do again, though there was not a weight assigned, here we are keeping the weight. Whenever we are keeping the weight, weight will be divisible by the elements which you have selected. Why we are doing then? If you have a question, I must have to tell you, like for finding out, here our target is the minimum cost. Though we are targeting the minimize the cost, so here also we are focusing those set which have the minimum cost. How do we find then? If the if you can say if S1, as per the example previously, okay, previously I have taken this one. If we initialize with the weight, so the number of elements are 1 2 3 and the weight is 2, then how do we say this is a best option for us? We want to check for each element what the cost is for each element. If I am taking for each element, so that will be 2 by 3, because 3 are the number of elements and 2 is the weight assigned to each subset. So based on that weight, we find the cost of each elements within the set. This is what we can find it out. Okay, for each element, for selecting, if you're going to select it, the cost you have to pick for each element. If it is less, then we are picking the set. Okay, this is what it represents. Next, delete si. If you have selected this one, you have to delete that from R, means the number of elements as we have done earlier. The same thing we are doing, but we are just focusing on this concept because we are focusing on the weight assigned to each element. If it is not one, then we have to focus this one. If it is one, so definitely the previous one by something, if you are doing it, okay, suppose you just think if it is one by something, so you will be definitely focusing on the one weight assigned to each. Better than you can focus on the k also, the number of k. If it is set as 2, then why not you focus on 2, not to make it more complex, because we are using algorithm to reduce to easy one. We are not making it so complex. Okay. Next, we have to do like we have to end of the while. Once we have done that one, whatever the sets that we have selected, that we have to present it. As for this example, what we did as greedy approach we have followed. So here the cost assigned to each element. Whenever we say there are sets, suppose I'm just naming that one as S1, here it is S2, here it is S3, here it is S4, and this is also a subset which is S5 and which is S6. Suppose our target is to minimize to find out the set cover. So as for the greedy, as I told you earlier also, the number of elements are definitely more here and the weight is 1. So 1 by 4, definitely we are expecting less amount. That's why we are picking S1. So the set cover here we are getting is, suppose C is a set cover. So for this set cover, we are getting this S1 first, because the more the elements will be picked the first and the weight assigned to each element will be less. S2, no doubt. I think it's understood by you. Why? Because 1 by 4. So element is definitely we are getting is 0.5 each. So like this we are targeting it. Okay. But we are not getting more proper solutions towards that. But at least we are trying to go for the approximation. This is what as per the algorithm it is written. Next, S1, S2, then S3 and S4. Because we want to have a cover, set cover here. Okay, so each element to be covered first. This is what we have to find out. But the optimal one, as we have already said as C star, suppose the optimal, if I am using these two subsets, okay, the cost you can say also the cost added or the weight assigned to each is 1 1. This is weight, okay, weight of 5. This is weight of 5. This is also weight assigned to each. This is also weight assigned to each. This is also weight. Okay, this is also another weight. Okay, clear. So this is weight wi. Okay, then how do we say was a cost here? 1 plus 1 plus 1, the number of subsets we have found out is 4. This is what we found using greedy. But if optimal you want to find it out, the optimal one, S5 and S6 will be the optimal for us in what region then? In this region. If I am saying in a weight or cost assigned to each subset, that is 1 plus epsilon, okay, 1 plus epsilon plus 1 plus epsilon. Epsilon is like as I have already told you earlier videos also, it's greater than 0 up to n, but we cannot guarantee like it's 2, 3, 4, 5, anything. Okay, so if I'm doing that one, it is 2 plus 2 epsilon. Okay, this is what our optimal weight assigned to the optimal cover which we want to find it out. But instead of getting 2 plus 2 epsilon, we are getting 4. You can say, sir, it's equivalent to that one. Yes, I understood. If I am saying epsilon is 1, so 2 plus 2 into 1 is equivalent to 4. But if I am saying if it is 0.5, then whether it is equivalent? No, it is less than 4. So the approach we are getting is 1 plus, 2 plus 2 epsilon is less than 4. Why? Because it depends on the epsilon value, it's already being there, it's already informed you earlier also. The epsilon value is greater than 1, it greater than 0, it is written here, clear. For that reason I'm saying, so we are targeting for getting the optimal solution, but we are not getting it. That's why we're using the we're taking the help of greedy approach, through which we are approximately getting the value which is nearly optimal. Okay, next, so also we should focus on the theorems. Here, whenever we are focusing on the cost part, okay, cost paid for each element. Suppose here, which we have already discussed. Now, if you want to change the value, certain, if you want to change the equations in certain way, so what you can write it, cost paid for each element. Suppose you are trying to find it out. So element named as S, small s, that will be represented as C, small c with a small s. This S represent element, a single element you can say, okay, element within a set or subset, basically you can say. This is cost per element, cost per element, which is small s, clear. Next, how do we define it? It can be defined like the same which we have discussed earlier. Next, that S, the small s, will be those elements which are being selected for the set cover. This is what we should have to rename again using the mathematical formula. So if C is the set cover obtained by the greedy set cover, so capital C, then whatever the cost, whatever the weight that you got is equivalent to those elements which is being selected from the universal, the cost will be equivalent to that one. Okay, so this is a lemma you can say. If you can say this one, like those sets which are being covered, like as we have already told, like by taking this example also, 1 by 4, 0.5, 0.5. So definitely if you add everything, so whichever that you have already collected will be the equivalent to the set you have considered. Okay, so if you want to check, like if I am enhancing the cost, if I am increasing one more element to it, so whether it is focusing on the load or the weight assigned to each element or not, this is what the mathematical formula it is written as. Okay, so it represents us to cover a lot of cost, means a lot of elements if you are trying to cover, so you must use a lot of weight for that one. Means each element is comprising of certain cost. If you are adding one more element to it during the set cover, so definitely you are enhancing the weight of it. Clear. So to make it so optimal, we have used harmonic function. The harmonic function concept, it is there in a physics, because whenever we are doing the harmonic motion, I think you have seen this one. This is called as harmonic one. Hence we are getting the curve or something. So for that we have to know the harmonic function or harmonic values or harmonic number, which is represented as h of n, and which is, again I must say, it is a combination of like 1 by 1 plus 1 by 2 plus 1 by 3 plus up to 1 by n. Here the n is the number of elements. If you want to find it out, this h of n, we are trying to find the value through which, if the sum of those values we are getting, this is what our harmonic function is. This is the concept we have used here. So if I am saying this, so up to n, this is what you can expect. I stands from 1 up to n, as I have already written there. Again also I can write it for simplification. You can say 1 by 1, I have already written, it is 1, 1 by 2, 1 by 3 up to 1 by n. The same value you are representing in mathematics, that you are adding it. Okay, summation of 1 to I, like this is 1, I stands from I starts from 1 up to n. This is what we have found out. Clear. So basically we should know the h of n runs within the ln of time, log n time. Okay, next our target is for set cover sk. Okay, for each set cover sk, the sum small s means the each elements within that set which is getting selected, the cost assigned to each element within the set is at most h of sk into w of k. Clear. This represents uh, like it's a lemma or theorem, you can say, through which at least we should know what the meaning of d here. The d is a, you can say, where we can say it's a number of elements within that. Suppose s1, I'm saying s1 is 1 2 3 4 5, so d represents the number of elements there, which is 5. This is what the value of d. Okay, so next is uh, u is a set, universal set. Next sk, the within that the certain elements we are getting to added here as s1 s2 up to sd. Okay, these are the maximum d that we have. Next, furthermore, let us assume that these are the elements labeled in order which they are assigning to each cost. Suppose we are saying the cost of each element assigned here is s of, suppose s of I we are trying to find it out. So s of j, basically c, small c, and s we are introducing j value. This represents for each element which are belong to a small j, that we are trying to find out the greedy approach of it, like, the cost for each element which belongs to c sj. Okay, next, certain thing like you can say certain up to j we have, and but we don't have the d value with it, and the d value we have to just focus, like as I have told you, like s1, the same 1 2 3 1 2 3. Suppose the d value is here is 3. So in this case, suppose I want to focus up to a d value, like up to this one. So I must say it is s j, then s j plus 1 up to sd. Why? Because this one is d. Click 3 one is completely d. So up to this we want to focus for a timing, like whether the cost assigned to each element which I have picked, whether it represents as h of sk into wfk or not, that we are trying to find it out. Okay, next is for this one, start with the iteration value sj plus 1 up to d, which belongs to r is, like we have already said, it has a number of elements equivalent to u. Okay, this is basically the harmonic function which we have. It's a sinusoidal function through which we have already seen the value, the wave. Okay, so next, if we implies this value like s of k, which belongs to r is a number of elements equivalent to the u. Basically, if you want to pick this cost, what the cost of this, at least the cost is equivalent to this or at least less than this. Why? Because SD is a element, the last point or the last value. What we did with, like if you want to check the cost, okay, assigned to k means the set k. Okay, here is a set k we are following, or subset you can say. So if you're focusing on a set k or a universal set, okay, R, so what you have to find out, each element having the cost will definitely be less than equivalent to d minus j, means up to j we focused and we left with the last element which is d. Okay, so definitely we will expect at least higher or equivalent to this. Next, what we did, if you can go in depth of to getting the each element how equivalent to how exactly it got the value, so the mathematical representation of it is written as this one. Okay, and for if you are saying this one, like the I value we introduced, like w of I, clear, is be like we have the value which exactly we have found out, the same representation we kept as it is, clear. Next value what we are trying to find it out. Next, suppose you are trying to adding of the inequality, this is inequality, you try to equate it. So what we did basically, I tried with the elements, all the elements, the which is selected within this subset, the cost exactly is equivalent to the cost of up to this, which is less than this cost that we have already discussed here, clear. Next, we are getting this value. If you can equate this, I must tell you, the value will be w of k d. I'm just writing that one again and I'm equating here, which will give you the better idea. W of k d minus 2 up to w of k divided by 1. Okay, so now if I'm taking the common of w of k, then it will be like 1 by d plus 1 by d minus 1 plus 1 by d minus 2 plus up to 1 by 2 1 by 1, or you can say just 1 by 1, because we are going towards 1 means before that 2 is there. Okay, so I'm just changing it, by keeping the same value as earlier 1 by 2. I'm just adding one more value to it, up to 1 by d minus 2 1 by d minus 1. I'm just changing that the value. So this is our harmonic function. This is our harmonic function. So definitely we must tell the wk, if you are just writing the harmonic function, so it will be belongs to, suppose you are trying to start with I, which is 1, this is d 1 by I, and this is h of d, clear. So this h of d will be written as w of k h of d. This d is s of k basically. It is, though I am saying it now, this d h of s k, because it is a number of elements, the number of elements with the weight assigned to that one, clear. Weight assigned to that one, we must tell this is what our value we can expect. If you are trying to find out the cost, at the most we have this much of value with us. This is what the proof that we have found out, clear. I hope it is clearly understood by you. Next is which is most important, like set cover, which we did as C using greedy set cover, has a weight at most h d star times, means sometime we are expecting, if you are compare with the greedy with the optimal one, how much time we can expect then. As we have already seen earlier, instead of getting 2 into epsilon, which we have done here, instead of getting 2 plus 2 epsilon, we are getting 4. Then how do we exactly express here? It is 2, it is h d star times more than the selected cover which we have done. Okay, so to equate with, we should have to focus on the earlier implications of 11.10, which we found out as this one. Okay, so the other side is, like, I'm just writing the other side also. Suppose it is S which belongs to S of K. Okay, the all the elements. Next, this is CS, those elements which are being selected. Other hand, it is there as H of HD, clear, HD into W of K. That we have focused, this is from 11.10. This is 11.10. Next, if I am focusing here, like the weight assigned to each, okay, weight assigned to each, whether it follows our condition or not, it must be greater than equal to, I have forgotten to write this one, equivalent to or greater than equivalent to. Next, I must tell W of K is greater than equivalent to 1 by HD, okay, sigma small s, means the elements set case. This is our expression from which we can get it. Next, if I want to say the weight assigned to the optimal weight, this represents the optimal weight. This is our optimal weight, optimal weight. This is optimal subset, optimal set cover, I must write, set cover. This is optimal set cover and this is optimal weight. We are trying to find out the weight as up to those subsets which are getting from the subset cover, which is C star. All the weights will be added and this is our optimal weight we can expect. So if I'm following this 11.10, we can use this value and we will get the same value here. Instead of HD here, we are getting SD star, and the same value we will be keeping as it is. Okay, this is S of I, C belongs to those values, and we will keep as rest as we have already done with the previous one. As we are focusing on the W of I, so here that's why I is getting used. Okay, and SD star you just keep as SD star as it is, no need to change it. For this, next we are just expecting a value, like suppose you are focusing on the the optimal value, the optimal set cover which you have collected. Again, those elements which you have taken from the optimal is either equivalent to or definitely greater than the cost which you have already found out. Clear? So this we have obtained. Next, if you equate with the 11.9, exactly, we are not going to do this right now. We are trying to just solve the inequality. Okay, so the W star we found. For this one, if you want to find out a W star, the weight assigned, W star means the optimal weight, which is a weight assigned to each subsets, which are optimal subsets, which we have already found out, is for this one, which is again greater than this value which we have found out, and this we have kept from this. Okay, and this is this SD star and S2 we are collected from this. Okay, so then once we have done with it, so next value I'm just writing, due to less space it's impossible to write everything within it. Okay, so I must tell 1 by HD star, then direct implications are there, so that's why it is quite confusing for you to understand. S of I, which belongs to C star, here it is getting multiplied with this one, small s, which is again we selected, small s belongs to S of I, then CS this is your, this is, as we have found out, clear. So small s belongs to u, the universal set. Cost we have selected is this much. So this exactly we are representing once we found out exactly here using 11.9. We can say the cost it already covered here, the cost it already covered for each universal. Definitely we must say it is equivalent to the set cover which you have done earlier. The set cover here is represented as the set which you have already taken as to cover belongs to set cover is C, and the weight assigned to each one we are just writing this as this. Clear. So to equate it, it's this much time means I must tell you, if I am equating it, so the weight assigned, basically the set cover whichever that we are getting, so it is the weight s of I must tell, which belongs to C, wi is definitely, it is has at most, this side we are keeping, other side hd star is getting multiplied hd star into w star. This is what we must tell, this is optimal one and this is what we have got. Okay, so this is at least this much of time we are expecting at the other side. Clear. I hope it is clearly understood to you, like how we have solved it and what is the set cover, what is the weighted set cover, what is the approximation, how it is getting used. This is the total thing we have covered up. So I hope if any doubt you'll be having, you please comment below. Thank you for watching. Have a good day.